Hi guys. This will be a more lighter show, more appropriate for the tea time. You can snack. So it's not going to be a marketing thing. It's just something that maybe emphasize the data that we have. So I'm going to talk mostly about trains today. That's real trains, not technology, anything, not containers or something. And I can say it all started a year ago when I was in New York. And I had a meeting in Boston, and then I took the train. And I saw on the train, it was like a 3-hour or 4-hour ride, that everyone was using their mobile devices. So afterwards, I was thinking, okay, maybe there is something in there that we need to research that maybe makes sense for us. Because us, as a startup, we're a platform for mobile, and we have actually a platform for advertising and a platform for social. So when doing that, what I wanted to check is, are people on the train, are they regular? Are they different from other people? Do they use the device, do they use it differently? And another thing that I want to check is the time on the train different for those people than the rest of the day? And when doing that, of course, I want to not refer all the weirders on the train, okay? All the regular guys. And of course, there are a few kinds of trains, and we wanted to use and to see if this kind of data that we can observe, can it actually work for us? Can we use it in our business line? Or maybe we can do other line of product when looking at user-owned trains. And I can say that trains and user-owned trains are amazingly different, and the data that we saw is really different than the data that we usually research. So when looking at that, we need to build a project. Like every engineer, we want to build a project. The first thing is, what data do we need? What data do we have today that we can analyze, that can help us? Afterwards, of course, we can try to understand how to locate the tracks, because we don't want to put people that put pins on the map and try to build a polygon. We want to use crowdsourcing for that. All the data that we have today, we want to harness it to understand where the tracks are. After doing that, we need a plan how to identify the users on the train. It sounds very easy, but it's not that easy. I'll explain why. And of course, when doing that, we need to track their behavior and see what's so different about it, and to benchmark it not only with other users, but also to benchmark it against the same users on the time that they're not on the train. And of course, lastly, we need to sit with the product and see how it affects our business. So that was the plan. First of all, I want to really give a big thanks to our data team, especially the data science part of it. They did a lot of work there. So let's look about the data. So that's the basic data that we see daily. We see roughly 2 billion transactions per day. It combined out of a lot of types of data. We have data from the ads industry, like a request for ads, impressions, clicks, install, post-installs. That means events that users are doing after they installed an app for our advertisers. We have lots of location information, which most of this is based on it. And we have social information that maybe I'll explain a bit more later on. Coverage, we have around 240,000 apps using our SDK, which we can measure signals from. And we have roughly 570 million users that we see every month, unique ones. And until today, roughly 9 billion downloads of our SDKs. So that was the warehouse that we had that we can learn from. So let's start with the questions, right? So how can we locate a track? Sounds very easy to locate a track, but some interesting fact is trains move. Okay, so every bit of this 3 facts actually, sometimes they can help us to locate the track, and sometimes they're an issue that we need to overcome with the data that we see. So if we look about the train that moves, train doesn't move like cars. Sounds interesting, but if you want to look at trains and you look, for instance, you can look at rush hour. The rush hour traffic in cars can actually help us indicate trains. Okay, because if, let's say, we can collect signals, location signals from the device, and we like sample it every time, and we know the user, so we can actually follow the user across time. And now we have to determine if the user, even if we know that he moved in a specific window, we now need to understand how did he move. Okay, if it was in a car, if he was a pedestrian, or if he was on a train. So we have to understand, to use machine learning, of course, for that, to understand that he used trains, and for that, we need to characterize the train's movement. So a very important thing about trains, they have stations. So how do you characterize stations? Any ideas? We're not allowed. Okay. Okay, yeah, so interesting thing about tracks, you have several trains moving on the tracks. So sometimes it confuses you in the data because you can see on the same location, you can see people, but they're actually moving in a different direction. So you have to monitor that as well. Station, you see concentration of people in the station. Yeah, that's very right. And not only that, you know that, so how do you know if it's a station or just, just people that are not moving? So yeah, you have to look at the window and see that they stood and then they start moving. And you have to correlate the same location with users that continue moving. And another thing about stations, there are quite a pause inside the train movement. So if you locate signals of location of a train and you see that they stop, we don't know that they stop, by the way. That's another thing. But what you probably see more, you will observe more signals on the same GPS, on the same location. Because when you track someone on the train, when we do that, of course, we don't track it, we don't have signals for every second. Okay, it's randomly. We have random signals of the user. So we cannot take into account that every minute or every second that we see a user, this is how we can actually sketch the track. So we have to understand now what happened between one sample to the other sample. Okay? And station actually can help because the bigger chance that we will catch them. Okay, we talked about the concentration. Great. So stations actually are very good anchors, if you want to. But a few issues about it. So we talked about the non-continuous events that we have. Another thing is about the accuracy. Unfortunately, location GPS is not that accurate as you think. So we need to figure out now, and you will see it in a second. You need to figure out if the sample belongs to a train or not, because sometimes we see two samples that are 5 or maybe 10 meters far, and we need to understand if they're actually in the same location or not. Okay, what do you think this is? So this is a sample that we combined, of course, after cleaning all the clutter that we have from the location. This is actually the east coast of the US, and you see the white lines are the Amtrak. The Amtrak is the US railroad. The white lines that all the green is actually covering those is the Amtrak map. So you can see that actually we've done a very good job. And it's like the chicken and egg here. So when I asked before, if you remember, we need to find the tracks and then we need to find the passengers on the track. So since we're using the people to find the track, actually we're answering both questions at the same time. So the same users that help us find the track, actually those are the passengers that we need to track. Quite complex, but okay. Another thing that it was a very good picture, so I had to show you. So this could be in a gallery, an art gallery, but it also is the train in Moscow that you can see. An interesting story about this, after we did it, we noticed in Wiki that a large part of this is actually underground. Not like the Amtrak, which is all a regular train. Part of it is underground, and we were puzzled, but we got a very good coverage, and I don't know really how, but that's the fact. Okay, now let's talk about the behavior, which is the most interesting part of that, I think, today. So this scatter of dots represent the usage of apps of an Amtrak user and a regular US user. So in the middle where the dark points symbolize the part that is indifferent to both of them, and those regards to apps that actually don't care if you are a railroad user or a US user. I can give you some examples, like Facebook, Twitter. It seems that everyone uses them. It doesn't matter if you are on the train or off the train. Every time that you get a notification, you use it. So, but there are a few that are not, and we'll talk about those. So, after looking at the apps, okay. We try to characterize the people that are using trains. I don't think that you'll be surprised at the first part. So it's hard to understand if it's a business or student, but a lot of users on the train are actually working. So they're using Word, Excel. They're looking for jobs on the train. They got a lot of time. And payment solutions. Others are tourists. So they're using a TripAdvisor, they're looking at a place to stay. Again, makes sense. They're reading news. I can tell you that most of them, that's interesting. They probably have a lot of time on the train, so they're now ditching unnecessary apps and trying to optimize their devices and to clean and the memory files and stuff like that, and even to measure the internet speed, because probably on the train the internet doesn't work so good, which makes sense. And most of the people are using media. Most of the people, it's amazing. The number of people using media on the train is actually enormous, and it includes everything. I didn't put all the audio ones because there were too much, but they're watching, HBO and everything, and listening to music and podcasts and stuff like that. But in games, there is a very clear cut here, which actually I must say, I thought it would be different. All casual games are not for train. I don't know why. And I'm sorry for the guys here that play Clash of Clans because they think it's a strategy game, but it behaves like a casual game. So if you look at the Kings games like Soda and Top of the on the White Tiles, everyone is playing them off the train. But there are games made specially for trains. Cross puzzles and all those word kind of games. Probably played only on trains. Never saw it played off trains. And interesting stuff to see that the people that drive trains also use cabs. Probably students use Lyft and businessmen use Uber, but still. And of course, the Amtrak app is highly used, probably only by a train, as you can see here. Can I do that? Okay. Get this. So, after doing this research, they actually opened a vast other questions that we need to ask because it's not that easy, I'm sorry. It's one thing to detect users on the train and on the analytic part, offline, as you said. We have the same stack that most of you guys talked about with the Kafka and putting it in an analytic database and stuff like that. But how can we detect it in real time? Because our ad platform, for instance, if you want to use this for optimization or for targeting, we need to answer every request in less than 10 milliseconds. And I can tell you this is probably the easiest or the smallest part in those 10 milliseconds that we need to do. So how can we do it in a sub-millisecond way so that we can actually use it? I'm not going to answer most of these questions, right? Because this is maybe next year. It's very hard. I can tell you that some of the difficult questions in that is, you can actually, and again, I'm not talking about doing it manually. If you want to do it, we need to do it on a big scale, not on a specific track. We need to do it on all trains. So for that, we need to, like, one option is to do a polygon of every track in the world and try to do some kind of a geofencing mechanism and try to identify with the location where the user at in real time. I'm not sure there is a platform today that can handle this in latency that fast and in a scalable way, maybe in the future. Another questions that arose. So, is it contagious? Because trains is a social, okay? So it's very social train. I know that it doesn't seem that way, but if someone is using an app, do you think it is contagious? Well, it's a good question. I can tell you that it depends probably on the train, on the architecture of the train. For instance, the one that I took from Boston to, from New York to Boston is a train that only 2 people actually see what the other is doing. But if you look at more rural train, like metro trains, everyone sees what everyone is doing, then it's much more contagious. You can see concentration of the same app much more in this kind of a train, which is very interesting. It can really be useful for business. That's a question that I want to. So what do you think is more important, the user demographics, like age and gender and country, or the context of the user that is now on the train? So maybe we can do a quick show of hands here. Would you think that the context of the train is more important for business? Okay, so I want to ask the second question because as software engineers, I can use the complementary system and guess that the rest will use the demographics. But some of you are data scientists, so there is a bias thing here because no one likes to vote, right? So the answer is it depends. It depends on the campaign. And I'll give you an example. The user context is less relevant for campaigns like Facebook, okay? Because people that download Facebook and install Facebook, it's less relevant their current context. But if we talk about Uber, for instance, we can see a very good correlation between users that are riding trains and the need for Uber. So if we know that right now the user is on the train and he doesn't have an Uber app, there's a very good chance he will install it. So it depends. Another thing that popped into is UI and UX. If you know that the user is on the train right now, would you change the way you want to show the ad? That's just, a simple example, but the answer is of course you want to do it. Because the context is really binded to the UX of the user. Okay? So how can what can we do with this data? So there are so many things we can do with this data. I can give you some examples. The simple ones we already discussed. We can cluster apps that are more relevant for usage on train and just use it in the optimization mechanism that they will pop more for users on train. So that was easy because that actually was the initial part of the presentation. We can also segment users on the train, okay, in an offline procedure and treat it as an interest. Okay, so even if they're not on the train right now, it means something because they're different. So we can use that as well. We can also build products that turn for those users. For instance, we can build products using this data that can alert users that the train is late. Maybe it malfunctioned. Maybe it's too crowded and I don't want to use it. So this data can help us doing that as well. So, will we do that? So the short answer is no, we won't. The reason that we won't do that is after this research, I can tell you that although the users are different and there is a slight business incline that we can do with this, the audience that users that are using trains is so small, it's actually a so small fraction out of the users that we see today, and the operation cost that needed to handle those users is so high that probably the delta won't be relevant for us. So we won't do that. But for the longer answer, I can tell you that in this research we learned a few interesting stuff that can help us in many other research areas that we're doing these days. So, and we can do that. Before going to questions, if you want, I can tell you more about the text technology stack as well, but figured that you heard enough about it. I want to tell you about something else. I'll jump quickly here and tell you something about Soda, because everyone now is using this enormous shirt. And Soda is kind of a new platform for us. It's a few months old, and it's a social data platform. And the reason I want to tell you that is because of the data. The data is a bit different than the data that we used for the Ed platform. It can be, and it can serve us for many new, interesting, like a train research for the next year. The data that we see in Soda today, Soda, I can tell you in 2 sentences, is we're linked to many apps that are social oriented, like dating and messaging and social. They're streaming to us all their data, the raw data. We collect it, and in a collaborative platform, we actually process it with all other data that we have in our system, all other social data and data. And then after that, we actually provide an API, a real-time API for them to query us on the user, on the interest of the user, the profile of the user, intent of the user. The reason that I'm saying that is because it's a different technology stack that we need to have here, because now we need to digest not only events, simple events, like signal events, we also need to digest text events, images, social, of course, events like, dislike, stuff like that, social graph and stuff like that, and combine everything in that analytic database, which is, I can tell you, quite a pain. So that's it. That was the basis for the presentation. Do you have any questions about trains? Yes. Yeah. That's a very good question. I will repeat. There was a question about user privacy. So every bit of byte and data that we actually have and collect is fully anonymous. We don't have any real information about the user, even about the hardware ID of the device. Of course not any identify information. Every data that we're collecting is on a statistical basis. And this is the reason which it makes everything harder, because we cannot validate this information, for instance, with the Facebook profile, and we cannot validate it in any other way. So everything is statistically validated. Okay. Thank you.